What's up guys, we're going to be taking a look at this lab, excessive trust in client-side controls. This is the first in a series of labs on the topic of business logic vulnerabilities. This is not the type of problem that occurs when there are bugs in the code or the code doesn't do what the developer thinks. In the case of business logic vulnerabilities, the code does exactly what the developer thinks that it does. It's just that the code is not logical in every specific scenario. The scenario is important because when we think about business logic vulnerabilities, generally the code works so long as the user is behaving in a rational way that's expected by the developer. But of course, a nefarious actor is going to be deliberately behaving in a way that looks to expose any issues in the way that the underlying logic of the app has been constructed. They'll deliberately try and skip certain steps of an authentication flow, for example, or they'll deliberately inject parameters, something that a regular user is not going to do. And we find that the code, when faced with those unexpected scenarios, doesn't necessarily behave in a logical way. This particular lab is an example of that, and it's based around a very basic premise that's often used to illustrate business logic vulnerabilities. Let's take a look at the lab guidelines. This lab doesn't adequately validate user input. You can exploit a logic flaw in its purchasing workflow to buy items for an unintended price. To solve the lab, buy a lightweight elite leather jacket. Okay, let's access the lab. So we're here in the shop. We can see the product, lightweight elite leather jacket. It's $1,337. If you don't understand why the jacket is specifically that price, I'm not going to explain it. Let's log in first of all, as we typically do if we were purchasing something from an online shop. We're given a set of valid credentials. Let's head to the home page. Let's check out the leather jacket. Let's add it to the cart. And in the background, Burp is proxying or capturing this web request. In the top right of the screen, we can see that the cart is updated. We have one item in the cart. If we click on the cart, we can see the lightweight elite leather jacket, and we have the option to place the order. Notice as well that we're given $100 in store credit, but that's not enough to purchase the elite leather jacket. Here's a copy of the post request that adds the product to the cart. And we can see as part of the post request body, we have product ID equals 1. That refers to the jacket. We have a redirect parameter, which is not important right now. Quantity equals 1, fairly self-explanatory, and price 133700. So we can see that's the price in cents for $1,337. Now for a bit of fun, let's resubmit that post request unaltered. If we refresh the cart, we can see that we now have a second leather jacket added to the cart. Now something that a newer developer might forget is that front-end controls or front-end security are only really there as a guideline for the user. They don't actually secure the app in any way. Security has to really occur on the back end. And that's because anything on the front end, whether it's a parameter that's sent as part of a post request, or even JavaScript verification that runs on the front end, can be tampered with. It exists inside the user's browser who has control of the browser. And when we take a look at this post request, it originates from the front end. So this is a HTTP request that's sent from the client, the web browser, with a parameter price that's sent to the backend server. Now what should happen on the back end is that it double checks the price. Is that the correct price for this item? Because if it just trusts the information that's coming from the front end and says, okay, the price of this product is 1337 and doesn't double check in a database somewhere, it now means we've given control over the price of the item to the end user. And like we mentioned, this is a front-end request. We can control what's sent to the back end. We have control over the browser. So for example, if we change this to a different price, for example, 100 cents, and then send this to the back end, this shouldn't technically work. Let's send. Notice now we have an additional leather jacket in the cart, but the price has been changed to $1. Because the back end has trusted the parameter that's been sent from the front end or the client side. Notice the description of this lab. Excessive trust in client-side controls. A nefarious actor can completely bypass any client-side controls. Security has to take place on the server. In this case, it's clearly not taking place on the server because the server is trusting this parameter that's being sent from the client side. We can now purchase a leather jacket for $1. Now, we don't mind so much that it's going to cost money because we actually have $100 in store credit. Interestingly, if I decrease the quantity, it actually fixes the price. So let's empty the cart. Let's resubmit that post request with the price of $1. I'm just doing this because the objective of the lab was to purchase 1 leather jacket. I don't know what happens if I try and purchase 3. We don't need to worry about payment because we have $100 in store credit. So we can just click place order. Congratulations, you solved the lab. And we get the message your order is on the way. Sometimes there could be an automated dispatch here. In other words, the item has actually been sent to us physically, even though we didn't pay the correct price for it. Key takeaway here is when we have a shop, we should never trust data that's sent from the front end. There needs to be a record of how much items cost stored on the back end in a database somewhere. And if those two numbers don't match for whatever reason, then it's the value that's stored on the server that should take precedent, because the user can tamper with this front end information. This is something that used to occur quite frequently in the wild. There are stories of hackers buying items for a negative amount of money even, because they've tampered with a client-side parameter. I'm assuming that this happens less often in the wild in the modern era. Having said that, it's very common for a new developer to not fully appreciate that client-side controls can easily be tampered with, and true security has to take place on the server. So that's really the key takeaway. It could be outside the context of a shop. Could be something like form verification, for example. Just because we have HTML or JavaScript verification on a form does not prevent a hacker from sending a HTTP request directly to the server. So we still need to run verification on the server side in order to make sure everything is secure. So that's why this lab had the title Excessive Trust in Client-Side Controls. Alright, that's pretty much it for this lab. Thanks for checking out the content, and I'll see you guys in the next lab.